Good morning, guys. Happy Monday, and welcome to the fourth marking period. Let's make sure we get off to a hot start. Complete your daily lessons, your weekly Delta math, and you will have nothing but success in this marking period. I just want to talk about expectations for the daily lessons. You copy over your lesson in OneNote like normal. You complete the do now on your own. Then you go to your video, watch the do now. Watch me go through the do now with you, make corrections. Okay. And then fill in your notes throughout the day. You don't just copy over my lesson that has the writing on it. You write in your page like you normally would. Okay? Use the video to help you fill in all the notes for the day. Then I leave you extra problems. You complete those on your own. You check back later in the day for the answer key, where you again make corrections, see how you did. And then you're pretty much good to go. I just want you to make sure you're not just copying over my work, my worksheet in the content library that has all the answers. It really should be your writing. Okay, your writing for the do now. You writing down all the notes that kind of mirror what the video has. You practice the extra problems. You look for the answers. You should be making corrections. I should be seeing checks, X's with the correct work. Okay, you know the normal routine. Now, in addition to that, make sure you're checking in with me and message me, ask questions. If you just want to check in and say hi, whatever it is, just try to be in touch with me as much as possible. Also, make sure you have that weekly Delta Math due. It is due every single Thursday night at 8 o'clock. And then Friday, it's still available, it's still open, but not for the full 100% credit. So make sure you get it done by Thursday at 8 o'clock at night. Today's lesson is a review day. Last week we talked about a ton of coordinate geometry proofs. Now we're just going to kind of make sure we have all the fundamentals mastered, and we'll get a couple of practice problems done. So this do now, like I said, you should be completing it on your own first, and then checking in to see how you did. Alrighty, so number one, how do we find the length of a side length on the coordinate grid? Okay, so what have we been doing to find the length of a side? Alright, we make a right triangle. Alright, make a right triangle out of the side length. And then, remember, we use the Pythagorean theorem from there. Where the side length we're looking for in this instance is always going to be C, the hypotenuse. Alright, and you'll be good to go for that. You could also use the distance formula. However, we've really been stressing the Pythagorean theorem is probably easier. But if you like the distance formula, go for it. Number two, how do we determine if two lines are parallel on the coordinate grid? Same slope. You can look back at the parallelogram lesson. Remember how we showed something as a parallelogram? The opposite sides we showed are parallel. How did we know the opposite sides were parallel? They had the same slope. 3. How do we determine if two lines are perpendicular on the coordinate grid? What kind of slopes? Not same slope. Opposite reciprocal slopes. Alright, think about what lessons we've seen that. Maybe proving it's a right triangle. We showed two of the side lengths have opposite reciprocal slopes, and therefore are perpendicular and form a right angle. Or for the rectangle lesson, same exact thing, but we did it 4 times. So there's 4 instances where all the consecutive sides have opposite reciprocal slopes. Let's just talk about quickly how that looks. Maybe 3/4. What would the opposite reciprocal be? Remember to flip it and change the sign. Or something like -5. Flip it, remember that's over 1, so flip it and change the sign, so now it's positive. A couple examples of the opposite reciprocal slopes. 4, how do perpendicular lines form? Okay, or what do they form? Right angles. Always. It's first couple weeks of geometry right there. Next, 5, dilations produce what type of lines? Parallel or perpendicular? Parallel. Now, they produce parallel lines, but they also could end up producing the exact same line. Remember, there's an instance where they're parallel, and then there's an instance where the line doesn't change at all. And you're going to see both of those examples right now. So 6, line y equals negative 1/2 x minus 6 is transformed by a dilation with scale factor 3 centered at the origin. What is the equation of the line's image? So the new line, what's its equation? So this line here, y equals negative 1/2 x minus 6, our new line, the line's image, will look something like this. Y equals, same slope. This is convenient because it's in slope-intercept form. We can see the slope straight out. But it'll be negative 1/2 x and then something. Either a different y-intercept or the exact same y-intercept. In this case, we're going to have a new y-intercept. Why? Because look where it's centered. Centered at the origin. The origin, you can graph it if you'd like, but the origin is not a point that's on the line. So it's a point off the line. There's definitely going to be a new y-intercept. So we have to take that y-intercept and remember what we do to it. We multiply it by something. We multiply it by the scale factor. So negative 6 times 3 is negative 18. And that's it. Simple as that. That problem could be a little more challenging if at the beginning for the initial line, y equals negative 1/2 x minus 6, that's in slope-intercept form. Remember, they might not give that to you in slope-intercept form. So solve for y, and then you can see the slope, and you can see the y-intercept. Next, 7. Line y equals negative 1/2 x minus 6 is transformed by a dilation with a scale factor of 3 centered at negative 6, negative 3. What is the equation of the line's image? So basically the exact same question. However, the first one was centered at the origin, and this one's centered at some random point. So let's confirm, let's see if that point is on the line. So y equals negative 1/2 x minus 6. Let's graph it. Alright, and now let's see the point. Negative 6, negative 3. You could just look at it and see if it's on there, but plot it. And you could see, yep, it is a point on the line. If the center of dilation is a point on the line, like it is now, the line does not change. So yes, the multiple choice answer will be y equals negative 1/2 x minus 6. Or you'll actually have to write it out like we just did, and it'll say explain your answer. And we'll say something like, hey, the line doesn't change because that center of dilation, negative 6, negative 3, is a point that's on the line. Okay, so today's lesson here. Jim is experimenting with a new drawing program on his computer. He created quadrilateral team with coordinates t, negative 2, 3, e, negative 5, negative 4, a, 2, negative 1, and m, 5, 6. Jim believes that he has created a rhombus, but not a square. Prove that Jim is correct. The use of the grid is optional. Remember, they'll say that. Always want to use the grid. Because look at the quadrilateral here, guys. It's clearly not a square. Alright, so first, let's think about what will make it a rhombus. All four sides are equal to each other. How would it be a rhombus and then not a square? Hopefully you're thinking that there's no what. What does a square have? There are no right angles here, guys. Look at these. E and M are very clearly acute. T and A are very clearly obtuse. There's no right angles in there. So first we'll focus on, let's find the lengths and show it's a rhombus. So this side length is 3. This side length is 7. So it'd be 3 squared plus 7 squared is equal to Tm squared. Simplify. 3 squared is 9. 7 squared is 49. And that's equal to Tm squared. We have 58 is equal to Tm squared. Square root both sides. This is not a perfect square, so you can just leave it as radical 58. All right. Now let's repeat that process for all the side lengths. This side length is 3, and this side length is 7. So it's literally the exact same thing, guys, but instead of putting TM squared, we're putting the side length we're working with right now is ET. Alright, simplify. Same old deal. We have 9 and 49 again. 58. And now you have ET is equal to radical 58. Remember, guys, rhombus, we're showing 4 equal sides. So now that's twice, 2 more times. Tedious, yes. But it's very, very doable on a Regents exam. This would be a 4-pointer. We can definitely get these side lengths. Alright, so we have 7 and 3 again for the side length of EA. I'm going to go top right here. Get radical 58 again. And finally, AM. Another right triangle formed around the side length. You have 3 again, and you have 7. So we have 1, 2, 3, 4 equal sides. So what we can say is that quadrilateral team is a rhombus because it has 4 congruent sides. Now, it says he created a rhombus. Check, we got that. 4 equal sides, but not a square. We also need to prove it's not a square. We can't just say it doesn't have right angles. So what we have to do, we have to take the slopes and show that the slopes of the consecutive sides, so the slopes that are next to each other, we have to show that they are not opposite reciprocals. So I'm going to clear out these right triangles so we can kind of just re-lock in on the diagram here. So for example, ET, the slope would be up 7, right 3. Up 7, right 3. Now, think about the opposite reciprocal of that. If we flipped it to 3 over 7 and negated it, so negative 3 over 7, that would be the opposite reciprocal. So let's see for TM now. Is that the slope? So up 1, 2, 3. Right 1, 2, 3, 4, 5, 6, 7. So the slope of TM is up 3, right 7. Is that the opposite reciprocal? It is not. Flipped, but the sign was not changed. Alright, we needed a negative slope there. Just for the record, we're going to just show all the slopes. So your slope for EA is again up 3, right 7. And your slope for AM is up 7, right 3. So the point here is that the consecutive sides, so what do I mean by consecutive sides again? Let's just review that. So for example, ET and TM, those are the sides that are next to each other. Those slopes, one of them is 7/3, the other one's 3/7, those are not opposite reciprocal slopes. Therefore, they're not perpendicular and do not form right angles. Okay? So we can say that this quadrilateral is not a square because the slopes of the consecutive sides are not opposite reciprocals, meaning they are not perpendicular and do not form right angles. So really the exact same explanation with not in front of a lot of this stuff. Okay, it's not a square because the slopes of the consecutive sides are not opposite reciprocals, meaning they don't form right angles because they're not perpendicular. All right, so a lot that goes into it, a lot to show, a lot to think about, but very, very doable. We can show all 4 sides are congruent, we can find all the slopes, and then your explanation is key at the end there. So try out example 2. It's basically the exact same question. All right, just gives you vertices, prove it's a rhombus, prove it's not a square. And these are both Regents questions, guys. Like we've talked about many times, the Regents just keeps repeating itself. So we have to be prepared for something like this. All right, good luck to you this week. Have a good, strong week. Remember, start of the 4th marking period. Get off to a good start. Daily lessons, Delta Math. Message me and remind. Have a wonderful rest of your day, and I'll see you mañana.